Wait. What? Okay. That was a reenactment. But a few weeks ago, my computer did die, just like that, right in the middle of a gaming session. Turns out my boot SSD catastrophically failed, giving me an excuse to rebuild my gaming rig, and my kids' machines, and every other system in my house with no SSD, no hard drive, no storage at all, and yet, look at this. I'm gaming, I've got Windows, I've even got a ton of games installed. How is this possible? I mean, I know you can download RAM, but downloading storage?
Well, kind of. The storage still needs to be somewhere, and luckily for you, KIOXIA, who sponsored this video, provided some of their CD8 Enterprise SSDs. But what he's saying is true. None of them are in the gaming PCs. Instead, it's all in here.
That is freaking amazing. Did you just pull one out so we got redundancy and everything?
Yeah, I mean, it's cool, but there are some disadvantages. Like, you kind of made every computer in your house a bit...
We'll get to that later. Roll the thing. I am really excited about this because in spite of the fact that network booting has existed for longer than Jake here, it's not something we've ever really played around with much, and certainly never for a home gaming setup. So how does it work?
Well, the current way to network boot from something like a NAS, network attached storage, is iSCSI. There is also like newer stuff like NVMe over Fabric, but as far as I know, it doesn't really exist, at least in Windows land yet.
And certainly it's not within the scope of this project. But as silly as it sounds to boot from a NAS, is it? I mean, you can video edit on files from your NAS. We do that all the time. You can game using files on a NAS. We do that all the time. So why not Windows from your NAS? It comes with some key advantages. For one thing, it centralizes your storage, which means redundancy can be more economical to safeguard against a drive failure. Instead of having to put at least 2 drives in every one of your systems, you can just put, I don't know, 6 drives in here, plus 1 extra for redundancy. And it can make for easy management of backups and lightning fast system restores.
Which I'm sure is great for kids' PCs, because I bet they mess stuff up all the time.
Mine are actually pretty good so far, but I'm sure that's coming.
My dad would be happy just because he could get rid of MSN Messenger faster. I wasn't allowed. I did it anyways. What I am allowed to use is deduplication or compression with ZFS as the backend.
That's super cool because it gives us even more efficiency out of the storage that we have.
But it's not all sunshine and rainbows. Like, what about the lack of system...
Hey, okay, we're gonna talk about that later. First, let's build a NAS.
Okay.
Why don't you tell us about this weird platform you decided to use for this project?
I hate this computer. This is the worst server I have ever played with, at least in like the last 5 years.
In fairness to Intel, it's a reference platform.
Software development platform.
It is never meant to go to an end user, but it has been a little annoying to get working. The good news is it's a super cool system. It's dual 144 core processors, which is hilarious overkill.
It's not even great for this setup, actually, because iSCSI not super multi-threaded.
But he's been looking for an excuse to tool around with it, and now we have it. But aside from the CPUs, we've loaded this thing up with an NVIDIA Mellanox ConnectX-6 dual port 100 gigabit per second NIC. We don't actually need the fastest network cards in the client PCs. But what we have to consider is that because this one machine is going to serve all of them, it needs to be as fast as all of their network cards combined. That is, assuming that they're all trying to hit it at the same time.
I mean, you wouldn't want your computers to be slow, right?
No, I really wouldn't. And with the speed of these CD8 Gen 4 drives that KIOXIA provided for this little thought experiment, we can use as fast a NIC as we can possibly get our hands on and never have to worry about our drives being the bottleneck. Now, what are we using for networking? Because I don't have a 100 gig switch.
Yeah, and Ubiquiti doesn't make one yet. So instead...
Hey, our buddies from Microtech!
This is the CRS51816XS2XQ. Not only does it have 2 100 gig ports, that's the 2XQ, but it has 16 25 gig ports, which is perfect. We plug our server in here, and then we can plug in all the other things downstream to the 25 gig ports.
At least we could if we had 25 gig networking in any of our systems.
Well, we're going to.
The funny thing is, as silly as it feels to use these CD8 drives for gaming, this kind of an application is not that far off of what drives like this are designed for. They've got die failure recovery as well as power loss protection and parity protection to make them extraordinarily reliable. They're available in capacities much higher than the 3.84 terabytes that we're deploying here. So if you've got simulation work or you're storing gigantic high performance databases, something like this would be perfect. And we're gonna put games on it.
And Windows.
So we've allocated about 10 terabytes of storage for a shared game drive and about 1 terabyte for the boot drives for each of our systems. We've got network, we got storage, that's all we really need. You're gonna take us, I don't know.
You got it.
That's fine. I got the whole thing.
Don't drop it, all right?
Oh my God.
What the
Oh, there wasn't a drive in that tray, we're good.
What the hell?
While Jake gets things hooked up, let's talk about the long-term plan, because obviously I'm not gonna be keeping a 288 core Intel reference server in my house to boot my computers. What I actually want to do is take my 2 loud NASs and consolidate them into one quiet one. So take that 45 drives chassis, rip out the hard drive mounts, put in NVMe mounts, and then run them all off of that NAS software that I invested in. Whether or not we boot the computers from them, that kind of depends on how this proof of concept goes. Why are you taking the drives out? We just put them in.
Well, I told you this server's so great, right? It doesn't boot with SSDs in it.
What?
So you have to like let it boot and then you hot plug the SSDs back. We tried so many things. The Intel rep was like, it's my last day. I'm not even kidding. That is legitimately what happened. Good luck at wherever you go, but he's like, I took the voluntary payout. I'm leaving.
All right, let's go look at the software stack. Now my assumption was we were just gonna use TrueNAS for this because we love TrueNAS.
Yeah, TrueNAS is great.
But we didn't.
Yeah, I used it for iSCSI like a couple months ago and it was pretty slow. There's also this thing called Starwind vSAN, which there's a free version that they let you use forever on even multiple machines. You can have high availability for free. And it's like purpose built for iSCSI. So it's a lot easier to just set up and use for this exact workload. So why not, right? There is a bare metal install, but I didn't notice until I'd already set up the like Proxmox image version. So that's what we're using instead. It should still be performant. I just took our network card and our 6 SSDs and just PCIe passed through them.
Right, so if there's any performance hit for virtualization, it should be pretty negligible.
This system has 512 gigs.
Right.
But you have to like load it. So
Cool.
I just picked 256 because that's faster. And I selected 64 cores. I mean, this type of server is really meant for like a web host or like virtualization.
Many web hosts.
Yeah, like something that just parallelizes like crazy.
Yeah.
Oh, we can see we have our KIOXIA SSDs. Look at that, all 6 of them. Wow. And then I went ahead and created a ZFS pool. It does give you the option to like just make a RAID pool.
Okay.
It seems to be slower for some reason. The ZFS is cool because it has RAM caching. And it'll just put your files in memory, and memory is, of course, super fast.
So with RAID Z1, that means that one of our drives is not contributing to our overall storage, but it also means that we can lose any one of our drives, just like I did when I was in the middle of my game, and none of our systems should go down. We're gonna show the real world results of that live test where Jake ripped a drive out in the intro a little bit later.
After that, you make a volume, which is kind of just like a folder. So we've got one for our game drive here.
This really reminds me of the TrueNAS interface a lot.
It's like the TrueNAS interface, but like less crappy. You notice how like responsive it is?
Yeah.
And then for iSCSI, we have to make a LUN, which is kind of like a virtual disk. Now, some of it is just needlessly complicated. Now, Starwind does a good job of making it less complicated. Let's create one. iSCSI. Standalone because we're not high availability, it's just one system. We'll make it in our Linus Smells thing. We'll call it Linus Really Smells. And we'll 100 gigs and done. That's all you have to do, right?
So now I have a 100 gig drive and it lives on my network.
But how do you use it? That's the annoying part. This is the overly complicated BS I'm talking about. I'm sure there's a reason for it, but this is like the address of the storage.
Got it.
I don't know why the date needs to be in there. It's not supposed to be the current date or the date of creation. It's like the date you registered your domain. As far as I can tell, entirely arbitrary. You can set it to whatever you want.
One way or another, like any other network resource, it needs an address. But what is the difference between an iSCSI storage drive and an SMB shared folder?
Well, one is block storage and one is file storage. And if you don't care what that means, it's basically, imagine iSCSI like an SSD. It's the whole drive. It's meant to plug right into a computer, not be shared. And you can imagine SMB as like, here's a folder. You know,
right.
Multiple people can use one folder.
And they won't conflict with each other if they both try to read a file or write to a folder.
Yeah, because it's designed to handle that. Luckily, StarWind can handle both, you see? SMB share, that'll be for our games. Since most games, you install them to an SMB share, you can play them on multiple computers and it just works.
And then they're gonna use their local My Documents or Games folder for any save data or whatever else, hopefully.
Yeah. Some games, not so good.
Yeah, so this is gonna be a little hit or miss, but we can at least try it.
Yeah, and worst case, you can install a game locally.
Question for you. For this test, did you swap out my network card for the fastest one that we've got?
No. I mean, the one you have right now, an X540T2 dual 10 gig one, should, in theory, work just fine for this.
Yeah, I mean, if you think about it, 10 gig, that's way faster than SATA 3.
Yeah. But we could go faster. Let's go faster.
Ah!
I mean, how fast do you want your computer to be?
I don't know, I just want to see what this is capable of.
I think we should do the 100 gig NIC. There is a PCIe slot limitation. Your system only has a x4 connection.
That's the thing about high-end desktop platforms being effectively dead these days, is if you want to get into kind of weird home lab stuff like this on a consumer board, you're not going to have enough PCIe lanes. But
this one's cool. It still has a second Gen 4 x4 link to the CPU, not through the chipset. But this is a Gen 3 card. So you're going to get 4 gigabytes a second max.
Boom. Card installation. Let's go. Yeah. Dude, this is a x1 slot though.
No, it's x4.
No, it's x1.
Oh, well, what board is this?
Well, I got my Thunderbolt card in the x4.
Why?
Because it needs it.
Don't you have an Icron thing anyways?
Yeah, but I also have a Thunderbolt dock.
That like 1 gigabyte a second is all you're gonna get out of that.
Oh, a 10 gig then. At that point, I might as well just leave the 10 gig card in there.
Well, we could use this one. This is a ConnectX 6 card. It's only 25 gig ports, but it's Gen 4.
Oh, okay.
So we'll get 2 gigabytes a second.
All right.
How big do you want your drive to be?
Terabyte?
Oh, okay. I was expecting more, but
yeah,
sure, fine.
No, that's fine.
So the first thing we have to do, of course, is make the drive. Boom, done. Okay, and now we're done. You're officially iSCSI'd.
Okay, we should probably configure the BIOS then.
Yep. Since our computer doesn't have a disk to boot from, we have to tell it where to boot from.
Right.
And this is potentially more complicated and annoying than one might think. The easy way is to set up what we're going to set up on a USB stick and just plug it into the computer and boot off the USB stick. But then we'd be adding storage, and we said we were getting rid of that, right?
I guess.
So instead, we're going to use our router. Now, you might be familiar with a DHCP server. It gives devices on your network an IP address.
Yeah.
It can also give them other things. Specifically, where to look for storage.
Interesting, okay.
Yeah. Now, the router you have, a Ubiquiti Dream Machine, doesn't have the most advanced DHCP configuration, so you can only really tell it one location to look, which obviously doesn't work great if we have 10 computers trying to boot off of it, right? Because then they'd all be getting the same drive.
Right.
So we made it a little bit more complicated, and I'm running a web server that it talks to and tells it its MAC address, and then based on the MAC address, it responds with the disk that it's supposed to use. It sounds complicated, but honestly, it's like 30 lines in a script. Here, you can look at this. Like, this is the name of the device, and this is the disk it's supposed to go to, and this is the MAC address.
All right.
I'm gonna link all of the like scripty things we used in the description if for whatever reason you want to try to do this. What we're gonna be using to install Windows is Windows PE, or the Windows pre-installation environment. It's like mini Windows that most of the time is used for network installing Windows, which is what we're doing. You have to take the image that you make and modify it slightly, namely just to add the network drivers. In our case, that would be Mellanox drivers, and I've already done that.
Okay.
But it also means I need to modify this boot script because...
Which MAC address do you want?
Oh boy. Oh, wait, right. It should be 9.8.
Checking media presence. Media present.
Okay, we're good. All right, Oh, it worked. Wow, that's great. We are glossing over a lot of this, but you'll see the scripts down below. This would be the one that you would use to boot WinPE. We're glossing over so much. This is like
the glossiest video.
Lip gloss.
It's so shiny. Editor, can you make this shot just like really shiny?
Ew.
Is that like a filter?
Why does it look like wet? Set boot URL, that's like the file storage location. Initiator IQN is like the name of your machine. And then Sandhook, that attaches the disk. Yep. You can see his name, Linus. And this is the bits it needs to download for Windows PE and then boot. And then when you go to actually boot, you just change the Sandhook to Sandboot and then just comment all this out. And in theory, it should just boot. Okay, yeah, wow, look at that, we're in. So we're gonna mount a network drive that has our Windows installer on it. I don't know if it's strictly necessary, but I like injected the proper drivers into the Windows installer. Okay. You can do that while you're like selecting your disk. It'll say install drivers. Yeah, it'll just prompt you. I just did it because I didn't want to have to screw with that. It's
every time.
Every time, my God.
Oh boy.
Oh no, it's gonna do that thing. Why?
Okay, well no, I can just use this one.
I think you need to unplug the SSDs. This is the step that usually fails. Please, God. Please. Please.
God can't help you where we're going.
Ugh. This is the step that installs drivers. I think it's good. When I was researching this, everyone talked about how this is just like an absolute nightmare to do and like disable Windows Update and all this stuff. It seems to just work as long as you have a NIC that supports it.
We ran into one very modern NIC that just didn't support it. Those 10 gig KIOXIA ones that are in the LAN PCs. Yep. That's why when we were talking about this at the beginning of the video, we were saying 2.5 gig because we were using the onboard Realtek.
Yeah, I tried for days to get it to work, but their driver just refuses to launch at boot time. We're gonna boot into WinPE one more time because we have to make a registry edit. I'm not 100% sure if it's 100% necessary, but there's a ton of people that mention it causes blue screens if you don't. Okay. We're just gonna disable the page file.
To be clear, disabling your page file could cause more stability problems than it solves, so it's not something that we would recommend under normal circumstances. This is just experimental for now.
Is that just working?
Is this it? I think it's just working. This shouldn't be that cool to me, but I'm not gonna lie, it kind of is. I'm just using a computer like I would normally use a computer. I'm gonna install a program like I would normally install a program. There are definitely some red flags. You can see the active time of my boot drive here is 100%, and my average response time, while it's usually pretty reasonable in the sub 20 milliseconds range, occasionally it'll pop up to half a second. That's a yikes. You don't want to see that. Like, this is not a CPU issue, how long it's taking to extract this Steam package. I have a 7950X. Oh wow, do you see that? Average response time as it's testing random writes is getting into the multiple seconds. That's bad. Also, even these sequential results are a fraction of what I was expecting to be getting, even with the PCIe slot limitations. Oh wow. Even before the game starts downloading, okay, there it finally goes. Just the reservation process was taking up 100% of the active time of the drive. Still is, actually. Network is doing nothing. And to be clear, this is not the fault of those KIOXIA drives. They're just like, yeah, we'll send over storage if you guys are doing a wild project. Those are really fast drives. So this comes down to the limitations of our network infrastructure and our implementation. How's it going? Oh, you've got 4 of them working? Yeah. That's sick.
How's that?
Oh, it's terrible.
Really?
Yeah.
Why?
Just everything is terrible.
Like slow?
Oh yeah. Huh. Even just launching Steam. Took a while. Jake, I'm logging into Steam on this system and I just got a system lag spike that was so intense I couldn't move the mouse cursor. Whew! Not good.
There's something very wrong with the permissions on the SMB share, and it just like, yeah, oh, okay. It's not very happy.
It was an interesting experiment.
I want to know now if you can make it go fast.
Me too, but I think that's an experiment for another day.
I want to go unplug one SSD. I'm going to do it right now.
Note that we've got 4 systems running right now, one of which is actively verifying the integrity of... Oh, you did it already. Okay. Well, that's one thing it does well.
Was I supposed to wait?
But I think it might finally be time to talk about the disadvantages.
Which one? You made every computer in your house way slower. You added a single point of failure. So if that server has a problem, which it probably will, none of your computers work. And how are you going to fix that server? You don't have a computer to manage it with to try to fix it. It's great.
And you've added a whole bunch of costs that realistically, you could put 2 consumer grade drives in every one of your machines and run RAID 1.
And complexity and management headaches. But I'm just stoked that this works.
I think it's cool. And the fact that it would work with just about any computer, even if we wouldn't recommend doing this at home. Like, man, okay.
The fact that the real Technics work at all.
If we could tune it, something like a LAN cafe.
Oh, I could totally see this like that.
From a manageability standpoint, where you actually have an IT admin who's working on it instead of just a home user.
Usually when you have a big install base of hundreds of computers, you might use folder redirection. You have a local disk, and then you just like redirect the user folders to a network share or something like that.
That way you're optimizing your storage use through things like deduplication and compression. You're also making it way easier for IT to manage how much space everybody's using and make sure that if something gets accidentally deleted or intentionally deleted,
deep freeze.
It can be restored. But this is dumb.
I wouldn't recommend booting Windows over iSCSI. It does seemingly work, but
I would recommend checking out KIOXIA's CD8s. They're PCIe Gen 4 drives with NVMe 1.4 support. They use their 112-layer 3D TLC flash.
They're very fast, they're very great, and they have a whole lineup of other drives if they don't specifically meet your need.
And you can check them all out at the link down below. Thank you, KIOXIA, for making it possible for us to deploy Jake on fool's errands like this for extended periods of time, because it's pretty cool.
And look, now we can take those drives and build them into a new NAS.
Yeah, and do something usful with them.
NVMe and hard drives, that'd be pretty cool.
If you guys enjoyed this video, maybe go check out the one where Jake and I built a NAS.
For your house, which is no longer here.